All right, we have a quiz. Just make sure there is one desk separation between you and your neighbor. There's lots of space in the front. I'm going to just pass around take one question paper and pass it on. Take one question paper and pass it on. Take one and pass it on. Okay. Let's take one and pass it on. Okay, and obviously the last quiz for the semester will be next week. We're supposed to have one every week, but doesn't mean we'll have it every Thursday. Just be careful, right? So just take one paper and pass it on, right? And put your hand up if you have not received the paper, right? And put your hand up if you have a spare. Spare with you? Okay. Right, spare, if you have a spare question paper. So all of these quizzes, spare question paper? No? Okay. Yeah. All of these quizzes are part of your short test too, all right? All of these quizzes form part of your short test too. So if your friend or somebody is missing, they've pretty much got 0 in today's question. So when you add up all the quizzes, they come to 7.5%, which is, when you add up all the quizzes, it comes up to 7.5%, which is your short test 2 mark. Put your hand up if you need a question paper. Okay, just come to the front over here. And collect it. Yeah, just take a seat. Okay, and we will give you 10 minutes, right? All right, the timer is on the screen. If you wish, you can draw the working table, but the main thing is the state diagram for question 1. Right? If you've done enough exercises and you know how to do it without the working table, that's fine. Right? Okay, but if you need the working table, you go ahead and draw the working table, or what we call the analysis table, and then show the state diagram. Okay, the state diagram is the important part. Question 2, question 3, only one word answer, only one number answer. Question 2 and question 3, single digit answer. It's question 1, which is the main one. And that's why you'll see it's 15 marks. Guys, there's only one state diagram needed, all right? One state diagram. And it's only the milli one, not more. Come in. Just take a seat in the front row. Okay, so you'll get extra time, eh? Just look at the time on this one. Somebody was calling me here. Okay, if anyone is ready, wants to submit, it's fine with me. Just put your hand up. Okay, set. I'll give 2 extra minutes for guys who are struggling. But if you're ready to submit, you can put your hand up and I'll pick your paper up. And then we'll do the solution for this one. So which one is your answer in this one? Which one is your final answer? There's 3 state diagrams. This one, this one, this one.
This one. Also cancel.
Just cross that. Set. This is your final answer? This one? Okay, I just put down answer here. Eh? This is the one, right? Okay. Guys, put your hand up, get ready to submit. Unless anybody needs extra time. How many need extra time? Put your hand up if you need extra time. Right? Now, in today's lecture, we'll be doing project type problem, project level problem. Right? Okay. Anybody over here, guys? Right, put your hand right up, put your hand right up. Anybody needing extra time, you can put your, just leave your hand up and then I'll know. You need extra time? Oh, submission. Okay. Right. Okay. Right. Anybody here? Anybody? You need extra time or you're right? Submit, okay. Okay, so how many guys still doing the paper? That's okay, I'll give you guys extra time if you want. And then we'll just talk about the lectures. Yeah, okay, put your hand up. Hand up. And the problem which I want to attempt in today's lecture, the problem which I want to attend in today's lecture is a problem which is similar, and if somebody is lucky, because there's only so many combinations of the bit patterns, if somebody is lucky it might be from the project combination, right? So I'm just going to generate a random number, see. Okay, anybody still doing the paper? Okay, guys, just to let you know, we've been having a quiz every week, and this quiz is part of your short test too. So when you sum up all the quiz, marks, and quiz 3 mark, I will be uploading it shortly. So if you sum up all the quiz marks, quiz 1, 2, 3, 4, 5, right, you will end up with when we look at all the quiz marks which you've done, let's see over here, right, in your mark sheet. For those of you who are not aware, you've got mark sheet. Short test 1 was out of whatever it was, I think 45, and then you've got your short test 1 mark of percentage over here. Then short test 2 is made up of quiz 1, 2, 3, 4, 5. 3 I'll upload. The mark has just come in and I will be uploading it shortly. You can, if you want, have you done the quiz? Yes, you've done the quiz? Okay, all right, okay. So if you add up all the quiz marks, let me just show you. Okay. All right. So quiz 1, so this is the way it works. Quiz 1 is 0.5%, quiz 2 1.5, quiz 3 2, quiz 4 2, quiz 5 2. If you actually add this up, it's 2 plus 2 plus 1.5 plus 0.5, that's actually 8%. Right? So if it weighs up to 8%. So whatever you score in that, whatever you score, so for example, if somebody scored, let us just say, 7.75 out of 8, what we will do is, this is what you call super percentage. We won't multiply by 7.5%. You'll get maximum. So I'm giving you 0.5% extra. That's what I'm trying to say over here. I'm giving you 8% worth of quiz, and we will count whatever you accumulate over there. So you can accumulate 8 out of 8, right, and you'll get 7.5. Or you might accumulate 7.75 and you'll get 7.5. Or out of those 5 quizzes, you would maybe have scored, after counting the final 5, you may have scored 6 out of 7.5, right? And they'll continually be updated on the Moodle shell. You would have scored 6 out of 7.5, 6 out of 8, you will still score a 6 out of 7.5, right? So whatever sum you score, that is the sum. So I've given 0.5% extra, right? So that's why it's important to attend every quiz and chip away at every particular thing. So we won't have a separate test 2 altogether. These quizzes, they form your test 2, all right? Okay, so everyone submitted their paper? Anybody still got the paper? All right, one last guy. Okay, right, so let me show you the solution. Okay, right, so this is why it's important to attend lectures, yeah? And sometimes I put stuff on there which is important. All right, let's see your question paper. What is the question about? So it's a milli machine. Tuesday's lecture and Wednesday's lecture, we did both of them we did milli machines. Tuesday's lecture, can somebody tell me what was the code? What was the combination in Tuesday's lecture? I know Wednesday's one was 0111. Yesterday's one was 0111. What was Tuesday's one? 1011. Not much difference. It was 1011 and this one here is 1010. All right? Okay, so not much difference, just 1 bit difference. Now, let me show you. If you are lucky, let's see if we are lucky, 1001. There we go, guys. This is directly from our Moodle shell. So if you are looking for the solution is here. So in your free time, go through this particular table, and you should have had an answer which looks something like this. All right? That's your answer. And this is, I didn't create this afternoon. This link and this has been there since 2021. All right? So when I was talking about yesterday, problem 2, okay, so problem 2.
So our topic for today.
In fact, these, boy, I was watching my own slides. It was take a long time to draw all this. Let's see. Come on.
Next stage. Why?
Yeah. So basically, if you want an explanation, if you can't understand the PDF, so I've given both there. I've given the videos, right? All the videos are there, and if you want to catch up with the explanation is here. But of course, you've got to scroll all the way till the 1 hour, 30-minute mark or somewhere along there, right? Okay. So it's problem 2. So problem 1 and 2 is in this first link, and problem 3 and 4 are in a separate link. And if you want to see, if you don't want to watch my videos, you can just look at this PDF file, which is over here. You can just come here and have a look at the PDF files. And problem 1, we did this on Tuesday. We've done a replica of this on Tuesday. Problem 2 is in your quiz. Problem 2, this got absorbed into your quiz. We did a separate problem 2, a different problem 2, which was 0111 for milli machine. Today, I want to take you to this level. I want to now take you to the project level, right? So that at least this weekend, you can, if you haven't been attending lectures, you can do problem number 2. Where's problem number 2? So problem number 2, you know, it's a big wordy thing over there. You know, all it's saying is, you've got 3 bit patterns. So the question is this: you've got 3 bit patterns. Every student has got 3 patterns over there. And you've got to, your light has got to, or your output has got to be 1 when any of these 3 bit patterns are detected. Right? Now, the other thing, if you've been doing your project, so let me just get a quick feedback. How many of you have attempted problem number 1? Attempted. Okay. Completed problem number 1. So some of them will go down. Completed problem 1. All right. Okay. Problem 2. How many of you have attempted problem 2? Started problem 2. Attempted or started at least. Problem 2. How many of you have completed problem 2? Nobody. Okay. So at least you've got this weekend. Any of you want to use the labs on Saturday? Anybody of you require the use of labs on Saturday? So I'll request the technician to come in. Any of you want to use the lab this Saturday? Yeah? ICT lab is fine? Right, so if you request, then you've got to show up. They'll keep a record of who, you've got to, then, you know, it'll be useful for you for later semesters, right? I think 212, you guys are doing a hardware project, right? Okay, and you're using the lab there anyway? Is the lab being opened on Saturday for 212? All right, so anyway, forget about 212. 222, I will ask for lab, the ICT lab to be open. All right, ICT lab to be open. Around about 9 o'clock is okay with you guys? 9 a.m.? Is that fine? So you can use it if you wish. If you want to have a group meeting there and, you know, do your project in groups, that's fine. That's the whole idea. Now, the other thing about the project, guys, because we've only got 1 week to go. And by now, through your own initiative, you should have started attempting problem number 2, right? And the reason why I gave you that quiz question is, if you don't do the project, you won't know what's happening in the quizzes. They're all tied in together. Now, in both question 1 and question 2, you would have seen that I give you some kind of combination. I say, hey, you use D and JK, whoever this guy is. Is this guy here? S1119737. Is he here? No? All right, okay. So, for this person, he's got to use D and JK. What do we mean there by that? We mean, let us say he has 4 flip-flops. Let us say he calculates and he says, oh, I need 4 flip-flops. So, 2 of the flip-flops, 50-50. 2 of the flip-flops will be D and 2 of the flip-flops will be JK. It doesn't matter which sequence. If you want to have D, then JK, then D, then JK, that's fine. If you want to have double D, then double JK, that's fine. If you want to have JK, then D, then D, then JK, that's fine as well. So long as it's 50-50, half and half. Right? So that's what we mean over here. What if, let's say this person here, S1119880, he has to do T and JK. Is that person here? Okay, a lot of people missing today. All right, let us say, oh, he's here in the front. Okay, so have you attempted this problem? Okay, all right. So maybe you've got time this weekend, you've got tomorrow, you've got, remember there's no labs now, right? There's no labs. The lab will be available tomorrow, right? It'll be open, you can go in, the tutor will be there to help you. Now, T and JK. So let us say, let me give you, again, repeating that example. Let us say you need 5 flip-flops. You calculate and you go, oh shit, I need 5 flip-flops, right? Okay, so how do you do that? So in that case, obviously one will have an odd number and one will have an even number. So it's your choice. You want 3 T's and 2 JK's, that's fine. Or you have 3 JK's and 2 T's. Somewhere around the half and half mark, but obviously one will have extra because of the odd numbers, right? So please take note of this, right? So most likely you will end up with 4 flip-flops or 5 flip-flops in problem number 1. In problem number 2, it's 3 flip-flops or 4 flip-flops. How many did you get? You said you attempted problem number 2. How many do you? Still doing it? Okay, all right. Okay. All right, now let's come here. Let's do this problem. I'm going to do today's problem. I'm going to do it directly from the model shell. I want us to have a look at problem number 4. It's a hard problem, but it is a replica of our all right, okay. So let's have a read of the question. And it is a replica of our project problem. Replica, except for one change. I'm not sure, I don't remember. Okay, design a sequence detector. If you want to write this down, you can go ahead. But if this is on the Moodle shell, all right? So solutions, oh, sorry man, I forgot this thing. How many flip-flops will be required in the question, in the system of question 1? Now, how many states was there? Let's look at the question before that. How many states was there? 4 states. How do we know 4 states? Because it was a 4-bit system and it is milli. Milli, and it is a 4-bit system, therefore it will have 4 states. 4 states means in the state diagram you have 4 bubbles. Right? Okay, now, how many flip-flops? In order to achieve 4 states, in order to accommodate 4 states, what do you need to do? You need to have 2 flip-flops, 2 to the power of 2. What number accommodates that many states? So 2 to the power of 2. All right, now, let's look at question 3. So answer here, the answer is how many flip-flops? It is 4 states, which is equal 4 is equals to 2 to the power of 2. Therefore, 2 flip-flops. All right. With reference to question 1, if the system were to be a Moore model, how many states would there be in your state diagram? 5, right? So it is the milli answer, number of bits plus 1, right? In milli, the number of bits will always be the same. Now on Moodle or on YouTube, you will find some people doing 3 bits, but taking 4 states to do 3 bits. Taking 4 states. You don't have to take 4 states. All you need is 1 state per bit in milli, right? 1 state per bit in milli. Just remember that, all right? Okay, that's the minimized version. So remember how when we were doing combinational logic, sometimes you come up with a solution, but it is not the minimized solution. Not the minimized solution. Yeah, remember that? Right? So same thing goes over here. Right? So sometimes you will find solutions where they are doing 3 bits. Generally I came across people doing 3 bits but taking 4 states to do 3 bits. Right? That is an unminimized solution. So it will still work. If you build the circuit, it will still work. Right? But the difference is it is not a minimized solution. That's what I'm trying to say over here. Right? And if you have 3 bits, generally you should be able to accomplish it in 3 states. Right? And that is why, if those of you who attended the tutorials this week, the tutorial today, yesterday's tutorial, you would have done problem number 5, I believe, question 5, which was detect 111. And how many states did use 3 states for milli? For milli, 3 states, and obviously for more will be 3 plus 1 equals 4. All right? So answer is, over here, the answer is 4 states for milli plus 1, which is equals to 5 states. Okay, there we go, guys. All right, now let's move on with our question for today. Let's quickly get this question started. The good news is that we'll just so today is week 16, week 12, lecture 3, and this is 16th June 2022. All right, okay, let's look at our problem number. Is problem 3. All right, so I'm going to write it in summary, and I'm just going to say same as problem 4 from 2021 on Moodle. That saves me time, all right? Saves me time. All right, saves me time. So what is it? 1101, 1001, and 1010. Okay, so detect. So it's detect any of 1101 or 1001 or 1010. Right? Output to equal to 1. System resets. Right, everyone happy with that? Okay, so this is the question, guys. Those are the 3 numbers. So the question is saying that your bit sequence has to go 1 if any of those 3. Right? So this is similar to a security problem. Mostly sequence detectors are used in security problems. So let us say you have a top security lab, right? And there are 3 scientists who are allowed to go in. Scientist number 1 has a code of 1234. Scientist number 2 has a code of 7896, right? Scientist number 3 has a code of 5021, right? So any of these scientists, if they type the code in, they should be given entry, right? So any of them. Okay, so let's get started, and we will finish on time. All right. So let's start off with this table, and I was very happy when I was going around. Some of our friends were able to do the problem. They were doing the problem without even drawing this working table, which is not really required, but it makes life easier. It makes life easier. Past input string, current possible input. So this is right. We can call this X. Current possible input string, next state system output. We call this Y. All right, now let me show you. This table is fixed, right? This is just a working table. It is not. You might find people doing it all over this. There are people who can do this problem. I saw one student was just thinking, okay, if I get a 1, then I will go to B. B, I should get a 0. Then I should get another 1. So obviously, and he was drawing, one of our students today in our quiz, they were doing this problem in the mind. So that's what I'm saying. You don't need this table, but the table helps you helps me in explaining things to you. All right, now, okay, so let's say state A, we say system is empty, right? Or we could say no past inputs, current possible inputs. And it's always important so in every state, guys, in every state, there can only be one bit sitting on the current bit stream, right? So that is our starting table. Our table starts off like that. That is our blank table, right? Obviously, the past input string in state A, or the first state, by the way, the first state is called the reset state. Right? We call it the reset state. That means go back to the beginning, right? Restart. Right? Reset means restart. Right? It's empty, and obviously in every state, every stage along the way, there's only two possibilities. Either you get a 0 or you get a 1, and then you point outwards. All right, so let's now fill this up. Okay, what did we have? We had 1001, 1001, 1010. Set? Only these three possibilities. So let's kick off, guys. If you get a 0, is the first bit a 0 in any of those cases? No. Okay, let's put this here. If the current bit, if it is a 0, our current input string becomes a 0. And if it's a 1, it becomes a 1. Empty together with 0, you merge empty with 0, we get a 0. Empty with 1, we get a 1. And if it's a 0, no, we're not going forward. If it's a 1, are we progressing? Yes. So that will move to B. When we progress, we move to B. Otherwise, we stay at A. Will the output be? What will the output be? Output will be 0, because we can only get a 1 if those 4 bits come in. We only have 1 bit right now. So we only have 1 bit. How do we know? In this current input string, we've only got 1 bit. So we can never achieve that, at least until D. Because at D, we would have the first 4 bits. All right, now, we transfer whatever was ticked over here. We've got a 1 now. Now, 1 together with 0 gives you 1, 0. 1 together with 1 is 1, 1. Right? Now, 1, 1. Is 1, 1 available? Yes. 1, 1 is available in the first string. Yes. Clear? 1, 0. Yes. 1, 0 is available too. Check that out, guys. We've got 2. Both bits are accepted. Where? Because 1, 0 is available here, and 1, 1 is the first 2 bits of that. So we say, okay, we both progress, C and D. Right, so we've got to, both of them progress, but they've got to carry their separate paths. It's like a family tree. Right? Both of them will progress, but this one will go with the 1, 1 path, this one here will go with the 1, 0 path. Both of them progress, but they are separate progressions. Right? Now, what about your output? Output, we've only got 2 bits. We can't really make our answer right now. So we say 0, 0. All right, now, this here we put here as 1, 0. That there we put as 1, 1. Right? So both of them have progressed, so they need to be inheriting a state. Because both of them have progressed, then they both inherit a state. 1, 0 says yes, tick. So we move on to the next round. 1, 1 moves on to the next round. So it's like almost like two teams in the quarterfinals. They both move to the semifinals. Separate semifinals, but they both move on. All right? Okay, so they both move to the next round. In fact, that's a very bad example, because when you look at a tournament, that means there'll only be one survivor. This is more like in first year there was lots of possibility, lots of students. Second year, few people drop out. Third year, more people drop out. Fourth year, there's only a handful who graduate. Right? Fourth year, there's less, and then finally, there's only a handful who graduate. So that's what we are trying to say. Okay, now 1, 0 moves to the next round. Right? So 1, 0 together with 0 becomes 1, 0, 0. 1, 0 with 1 becomes 1, 0, 1. All right, let's check this out, guys. 1, 0, 0. 1, 0, 0. Anybody there with 1, 0, 0? Yes, him. So we say tick. 1, 0, 1. Anybody with 1, 0, 1? Yes, tick. So both of them go on. So what would be the next available state, guys? E and F. Would the output be a 1? No, it won't be a 1 because we only have 3 bits. We need at least 4 bits to declare a 1. Right? And in that even as well, we need 4 bits which have an exact match. All right, now, 1, 1. 1, 1 together with 0 is a 1, 1, 0. 1, 1 together with 1 is a 1, 1. Now let's look for 1, 1, 0. Is 1, 1, 0 available here? 1, 1, 0, yes. This guy. In. 1, 1, 1. Is he available? Out. Okay, so E, F. What's the next available letter? State. G. Right? A, B, C, D, E, F, G. Right, G. Right? 1, 1, 0. Yeah, 1, 1, 0 is there. All right, okay. Right. Output is 0. This one output is 0. Where does the 1, 1 go, guys? 1, 1. Okay, in this question it said that the system resets only if you find the final correct answer. Right? Okay, now, so in 1, 1, can we recycle 1? Can we recycle double 1? Yes, over here. D. All right, now, let's go to E. What are the ones which progress from the last two? 1, 0, 0, 1, 0, 1, and so 1, 0, 0 progress, 3 bits, 1, 0, 1, and 1, 1, 0. So 1, 0, 0, 1, 0, 1, and which other one, guys? 3 bits. 1, 0, 0, 1, 0, 1, and 1, 1, 0. Okay? So E, F, G. Well, there we go. E, 1, 0, 0, F, 1, 0, 1, G, 1, 1, 0. So that's where we get the numbering from. E is there, F, G. Right, so let me fill up this table, 0, 1, 0, 1. All right? Okay. Now, is the final countdown. 1, 0, 0 together with a 0 becomes 1, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 0. 1, 0, 1, 1. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 0, 1. All right, now let's go through the list. Let's go through the list. Okay. I hope you guys can see it. All right. There we go. All right, let's go. 1,000. 1, 0, 0. Available? Not available. Out. Obviously, he gets a 0. 1, 0, 0, 1. In the list, or you know? Yes. So he forms a 1. He gets a tick and he gets a 1. Why 1? Output is 1. But also, we note that the question said there would be a reset. Reset means go back to A. Do not recycle. If it was a recycle, okay, we will do that problem again in different color. 1, 0, 1, 0. Is he there? Is he in the list? Yes. Yes. So we say yes. 1. And we reset. 1011, is he there? No. So he gets a 0. We'll deal with this answer later. 1100, is he there? No. So he gets a 0. 1101. Yes. Output is 1. All right. And obviously it will reset. Okay. Now, let's see what can we do with this 1000. 1000. Is the 0 usable in anywhere? No. We have to go back to A. Right? Let's look at the next gap over here. 1011. Is the 1 usable? Yes. Something bigger. Well, if we go to 1, it will be B. What about double 1? Is double 1 usable? Yes. What about 011? No, there's no such thing as 011, only a double 1. So double 1 was available with D. What about 1100? 0, is it usable? So I think we are familiar with that. Right? What about 00? Is that there? No. What about 100? Yes, E. Okay? All right. Now, so this is our working table, right? And just to save time, this state diagram is still correct. This is the state diagram for that answer, right? Okay, now, tell me, we've got 5 minutes to go, tell me, so this is the state diagram, and if you are wondering where did Imran get the state diagram from, you come to problem number 4, that is our thing there, right, and then you've got that, right? So A to G is 7 states.